Okay, so first of all, let's talk about what a complex fraction is. A complex fraction is a fraction within a fraction. Okay, that's why it's called complex. So look at these first couple of examples. We've got a big fraction, but then within that fraction, we've got a fraction here in the numerator, we've got a fraction here in the denominator. And sometimes we have more than one fraction in the numerator and denominator. To simplify a complex fraction means we want to make it just a single numerator and a single denominator. We don't want any additional fractions within the big fraction. So what we're going to do is the first step is to create a single fraction in the numerator and the denominator. Now the front of this, we don't have to worry about that. It's already a single fraction in the numerator and in the denominator. But think about what a fraction really means. A fraction is really telling you to divide. So we've already dealt with dividing these rational expressions. What do? We multiply by the reciprocal, and then we simplify. Sometimes that's going to require factoring. Okay, so let's look at doing that with the first few examples here. Let's look at number 1. All right, so we have a over 2 over a squared over 4. So it's already a single fraction in the numerator and the denominator. So we keep the top the same. Okay, the a over 2 stays the same. We're dividing by a squared over 4. So division is the same as multiplying by the reciprocal. So this turns into multiplication, and we flip that bottom fraction over. So it's no longer a squared over 4, it's 4 over a squared. Excuse me. Now, we've dealt with these multiplication problems. Okay, I'm going to rewrite this so it's just a little bit more clear. Okay, a times 4 is 4a. 2 times a squared is 2a squared. Now, what can we simplify here? 4 over 2 reduces to 2. 4 divided by 2 is 2, so 2 goes in the numerator. A over a squared, remember we subtract the exponent, so 2 minus 1 is 1. It was bigger in the bottom, so a to the first goes in the bottom. We don't need to write an exponent of 1. So 2 over a is how this simplifies here. Okay, let's look at number 2. Okay, it's a single fraction in the top and in the bottom, so we keep the top the same, 6 over xy, times, we flip the bottom one over, and it's multiplication, 8x cubed over 3y. Let's go ahead and multiply here. 6 times 8 is 48, x cubed. And in the bottom, xy times 3y is 3x, y times y is y squared. Now, let's simplify 48 over 3. 48 divided by 3 is 16. X cubed over x, subtract the exponents. 3 minus 1 is 2. It was bigger in the numerator, so that's x squared in the numerator. And y squared, we don't have a y in the top, so we just leave it where it was at in the denominator. Okay, so not really that bad, not that difficult. We just need to keep things organized. Okay, let's look at number 3. Expressions are getting a little bit bigger here, but we still just have a single fraction in the top and in the bottom. So keep the top the same, 18p over 8p minus 2, times, flip the bottom one over, 4p minus 1 over 4p squared. All right, so we're going to multiply, but we're not going to multiply it out. So we're going to keep the 18p in front, and the 4p minus 1, we're just going to put that in parentheses. I don't want to multiply it out because our goal is to be able to simplify, and to be able to simplify, we've got to keep things in factored form. Now, with the denominator here, I'm going to put that 4p squared, I'm going to put that in front because it's kind of like a GCF. It's a monomial, so I'm going to put that in front. times 8p minus 2. Can we factor something out of 8p minus 2? Yeah, we can take out a 2. So we're going to go ahead and do that. We're going to do times 2. And when we factor it out, look at what we get. 4p minus 1. So we can cancel the 4p minus 1. And we can simplify. In the bottom, we have 4 times 2. Or you can look at it this way. 18 divided by 2 is 9. That leaves us with 9 in the top. Okay. And p over p squared leaves us with a p in the bottom, and we still have that 4 in the bottom. So all of that stuff simplifies down to 9 over 4p. Now, I haven't shown you how to check this yet, but remember we can always use our calculator. Whenever we're simplifying things, we check it by putting the original in y1 and the simplified version in y2. Now, the problem with that is we've got to be careful. We've got to put lots of parentheses in here, okay? So what we've got to do is we've got to put parentheses around each numerator and each denominator, and we've got to put parentheses around the big numerator and parentheses around the big denominator. So this is not the most effective thing to do, but it is possible. So that starts my big parentheses, and then here's my parentheses around the 18p. Okay, close those. Divided by parentheses around the 8p minus 2. Okay, close those, and then close my parentheses around the entire numerator. Divided by big parentheses. Okay, parentheses around the 4p squared. Close them. Divided by parentheses around the 4p minus 1. Whoops. Close the little parentheses. Close the big parentheses. Okay, so that's my original expression in y1. And then in y2, I put 9 over, I don't need as many parentheses here, okay, because I've just got a single number in the numerator, and I do need parentheses around the 4p in the denominator. What am I looking for? What am I looking for when I do this? I go to the table, and I'm looking for the same y values. Okay, I'm looking for the exact same y values. If I get the exact same y values, then I've done it correctly, okay, and we do right here. Okay, let's do number 4. K minus 1 over k squared minus 1 over k squared. All right, keep the top the same, k minus 1 over k, times, flip the bottom one over, k squared over, let's go ahead and factor since we're going to have to do it eventually. K squared minus 1 is the difference of perfect squares, so that's k plus 1 times k minus 1. So are we okay if I just kind of extend this line right here and put parentheses around my k minus 1 so that I can cancel? Okay, k minus 1, I've got that in the top and the bottom. I've got k squared over k. That leaves me with just a k in the top, and then k plus 1 is left in the denominator. Now don't forget, we are not allowed to cancel those k's right there. Okay, because k and k plus 1 are different expressions in this case. Okay, so we're not allowed to cancel those k's. That's all we can do. Okay, let's do a few more to make sure we've got this, and then I'm going to let y'all practice a little bit. Let's look at number 5. 7c plus 35 over c plus 5 over c squared. So, let's see here. What can we factor? 7c plus 35. We can take out a GCF of 7. That leaves us with c plus 5. Over c, nothing to factor there. Times, flip the bottom one over. C squared is now on top. C plus 5, nothing to factor there, so we just leave it as it is, put parentheses around it. Okay, so it's multiplication, so we're looking to see what's in the numerator and in the denominator. So we've got C plus 5, top and bottom, so we can cancel those. We've got C squared over C, that leaves us with a C. So we've got 7C is all we're left with here. It simplifies down to just 7C. Okay, let's look at number 6. B plus 2, nothing to factor there. It's a binomial, just put some parentheses around it. B squared plus 6B plus 8, we can factor that into B plus 4 times B plus 2 times, flip the bottom one over. So B squared minus B minus 20 is in the numerator, but let's go ahead and factor that. B minus 5 times B plus 4 over that 1 is now in the denominator. So what shows up in the numerator and in the denominator? We've got B plus 2. We've got B plus 4. So the only thing we're left with is the B minus 5. Dividing by 1 doesn't do anything. It doesn't change anything. Now, if that 1 were on top and the B minus 5 was in the bottom, then yeah, we would need to write the 1. But dividing by 1 doesn't change anything. So it's just B minus 5. Okay, number 7. Let's look at number 7. 15 minus 15R. We can take out a GCF of 15. That leaves us with 1 minus R over 15R squared. It's a monomial, no factoring to be done there. We just leave it the way it is. Okay. Times, now that denominator there isn't a fraction. So how do we flip it over? Well, how about we make it a fraction? Just put it over 1. Okay, so when we flip it over, it's 1 over, and 12R minus 12, we can factor out a 12. Okay, so let's see here. What can we cancel? We can cancel the 15s. And right now, that's all that it looks like we can cancel. 1 minus R and R minus 1 are not exactly the same thing. But let's do this. Let's rewrite 1 minus R in standard form. So negative R plus 1. Okay, rewrite 1 minus R as negative R plus 1. Now, what do we do when the first term is negative? What do we do with that? Take out a negative, right? So that changes our signs. Well, that's good, because when that changes our signs, we get R minus 1, which is what we have already. We have that factor in the denominator. So all I did with the denominator was I wrote my 12 first, because constants like that always come first, and then the R squared, and then the R minus 1. So we can cancel the R minus 1s, but don't lose that negative right there. Okay, you cannot lose that negative right there. It's negative 1 over 12R squared is the correct answer. Okay, almost there. Let's do one more example here, and then I'll let you practice some. Okay, number 8. Because this is so big and there's a lot of factoring to do, and I don't have a lot of room, I'm just going to factor in this first step, and then I'll do the flipping and multiplying. So in that first numerator, we can take out a GCF of 2. So that leaves us with m squared minus m minus 20 over, in that first denominator, we can take out a 3. 3 times m plus 4 over, big fraction here, m cubed minus 5m squared, we can take out an m squared. So we're left with m minus 5. And in that last little denominator, we can take out a GCF of 9m. So that leaves us with m plus 4. Okay, that very first expression there on the top can be factored further, so I'm going to do that here in this step when I flip it. Okay, so m squared minus m minus 20 is m minus 5 times m plus 4. And that's still over 3 times m plus 4 times, flip it over. Okay, so the bottom one flips over. 9m times m plus 4 is now on the top, and m squared times m minus 5 is now on the bottom. When we're multiplying, it just becomes one big happy fraction. So what can we cancel? We can cancel m plus 4, m minus 5, 9 over 3 leaves us with just a 3. And m over m squared leaves us with an m on the bottom. So let's see what we've got left here. We've got 2 times 3, which is 6, and a factor of m plus 4, still in the numerator. And in the denominator, all we've got left is that m in the denominator. Okay, so I told you the factoring wasn't going to go away. You got to keep working on this to get better at it.